Welcome back to Alligator Wrestling 101, where we're going to learn how to wrestle us some gators. I'm just joking. We're actually going to be going over organic chemistry practice problems today. So, with that being said, let us begin with some practice problems. I'm going to walk you through these step by step and hope you can grasp the concepts. Some of my videos actually explain most of these concepts and reactions, but there might be a few new ones thrown at you that you don't know, and I'll explain what those are as we go along. But let's start. So, MeMgBr plus H plus, we know, is going to be a Grignard reaction, which is going to give us this molecule overall. And always do make sure to count your carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we are correct. So with that being said, the next step is KMNO4 with NaOH. Now this is a reduction. Actually, it's an oxidation. And it will oxidize this bad boy right here. But this alcohol right here is actually protected because it is tertiary. So we will actually be given a product that looks like this. Now when we react this with H plus / Adine Stark, this is actually a cyclization. It actually causes water to leave. So this will actually end up leaving, which will open up this orbital right here in order for our oxygen to come in and attack. So when we do that, make sure you number your carbons from oxygen to the ketone. 1, 2, 3, 4, 5, and 6. And then draw out your 6-membered ring. Oxygen at the 1 spot. At the 2 spot, we actually have 2 methyls. At the 3 spot, nothing. At the 4 spot, nothing. At the 5th spot, nothing. At the 6th spot, we have our ketone. So when we react this with dibol H, this will reduce our ester into an aldehyde, giving us, oh, 1 second, a product that looks like this right here. And then if we do have then H plus, we would of course, oh no, we would of course then have an H tacked on to this oxygen like this. And the hydrogen that attacked is actually right here, if you want to know where that was. And that would just reduce the ester into an aldehyde. And to make this prettier, let's draw it out in a more realistic manner. 1, 2, 3, 4. 1, 2, 3, 4. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. At our 5th spot, we have 2 methyls, and we have an OH. At our 1 spot, we actually have our aldehyde like that. So moving on to the next step, pH MgBr in excess. Now we have to remember we need this in excess because if we only had one equivalent, the only thing that would happen would be deprotonating the hydrogen, giving this a negative charge. However, since we do have excess pH MgBr, we can actually deprotonate that hydrogen, and then we can actually add on here, giving us this product right here. Now the H's are on there because we do have then H plus. But that is your overall product. Moving on to the next example. Well, hello, Wittig reaction. Let's do a little German chemistry. So starting with the starting molecule, we're going to start it off with a Wittig reaction. I actually forgot to draw in the plus and minus. This is plus, this is minus. This is how you'll be given these molecules and reagents if it is a Wittig reaction. As I taught you in the previous video, draw in your double bond from the plus to the minus, split that bad boy, and then split it at the aldehyde. Ignore the ketone because the ester, because the ester is an acid derivative, and Wittig reactions do not react at acid derivatives. So we will react it at the aldehyde, giving us a molecule that looks like this. So now then, when we do 2 times NaOH touch H2O, the first thing that's going to happen with the first NaOH and H2O is a saponification. So your first intermediate with this reaction would look like this. Since there are 2 equivalents now of NaOH and H2O, we can actually do what's called an Anti-Markovnikov addition. Now, what is anti-Markovnikov and Markovnikov? Well, Markovnikov looks like this. If we react, say, Br with this molecule, and we're adding it on via an addition, Markovnikov and anti-Markovnikovs add on at the alkene bonds, I should state that. The Br would actually add on at the more stable position, which would be the tertiary carbon right here. If we are reacting this anti-style, anti-Norton security, we add on the Br at the less stable position. So that's the basis of that principle, and NaOH and H2O can do an anti-Markovnikov addition. It's an anti-Markovnikov hydration, basically. It will add an OH on to the alkene bond, and since this is anti-Markovnikov, once again, our final product will look like this, because it is anti-addition, not Markovnikov. I guess it is still Markovnikov, just anti-Markovnikov. But moving on to the next example, we have a molecule that looks like this. And I don't know what happened there. It looks like somebody got into my notes and erased some stuff. But with that being filled in, let's start this reaction. So, first step that would actually happen here is you'd most likely get a cyclization. So instead of having your molecule like this, you would actually get something that looks like this, and that's because of the presence of this H+. However, since we have MEOH around, hydrogen can attack again, making this leave, giving us this product. And this would be our product from this reaction. Now then, when we react this with H2CrO4, H2CrO4 does the same thing as KMNO4/Camino. However, it is much stronger, and it can actually cleave rings and oxidize. So it can actually cleave this ring, giving us this intermediate. Let me draw this out. 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, and then 5. And then we would have OMe here, and we would have at our 5th carbon an oxygen. And what this does is it will then oxidize these carbons, turning them into carboxylic acids, giving us this product right here. Now when we react this with ETOH and H+, in the presence of heat, what's up my boy Charmander, we will then actually add on the prefix of the alcohol to the carboxylic acid, and that is because of the presence of this heat. So Charmander, do your pleasure and perform flamethrower on those carboxylic acids and add on ethyls for me, giving us this product right here. And once again, the best way to think of this is if you do have ETOH or MEOH or any carbon chain alcohol / H plus with heat, and you have carboxylic acids, is find your carboxylic acid and then add on the prefix. And these also do the same thing as MEOH / H plus, but the heat allows it to actually add on to the carboxylic acids like this. So with that being said, moving on to the next step, one equivalent of NaOH. What would that do? That would just do a saponification. A saponification would take one of the ETOs and leave the oxygen negatively charged and giving us the byproduct ETOH. So that would give us a product that looks like this right here. Now when we react this with excess pH MgBr, we can do a Grignard reaction at this ester. However, we cannot do a Grignard reaction here because of this negative charge right there. Remember, we don't want to have negative charges too close to one another when we do Grignard reactions. So what would happen here is resonate up. The first one would then come in and attack, and then this would actually leave, and the second Grignard would come in and attack. So we would actually get two Grignard additions at the ester, giving us a product and since I did put no H plus, we would have a minus sign there. A product that looks like this. Now when we react this with DMSO and H+, we're actually going to get a cyclization. So the first step would be replacing our negative charges with the H's because of the H+, and then the DMSO acts like a Dean Stark, so water would leave here. So we can now open up this orbital, and we can actually have this oxygen come in and attack the orbital. So we will now number 1, 2, 3, 4, 5, and 6. Draw out a 6th-membered ring. Oxygen at the 1 spot. At the 2 spot, I'm going to have 2 pHs. Do remember you can draw this anywhere, it just has to be correlating with your numbering system. Since it is a benzene ring, the positioning is superficial. So as long as you number it correctly and you have them the same distance apart as they are on the linear molecule, it is correct. You could also have these flips. You could count counterclockwise or you could count clockwise. So 1, 2, 3, 4, 5, 6. We would have our ketone and we would be given our final product. Now, with all that being said, I hope you guys found this helpful. I'll just keep doing some practice problems and you guys can enjoy. So, have a wonderful day.